Hi everyone, let's begin our unit on earth science by talking about rocks and minerals. Now rocks and minerals are found in the earth, and the ground beneath our feet, the earth itself, that has a scientific term called the geosphere. And this geosphere, the earth itself, is made up of rocks. And if you analyze these rocks a little bit further, you see that they're composed of minerals. So let's begin with minerals. In order to call something a mineral, it has to satisfy several criteria. It has to be naturally formed, which means cubic zirconium is not a mineral because that's made in the laboratory. It has to be inorganic, which means not composed out of living organisms, such as, plants and dinosaurs from long ago that were decomposing and transformed into coal. So those aren't mineral. Coal is not a mineral. To be a mineral, it has to be a crystalline solid. So there has to be an ordered arrangement of atoms. The opposite of crystalline is amorphous. An example of an amorphous solid is glass. Okay, so glass is not a mineral. It's not a crystalline or ordered array of atoms. And then finally, to be a mineral, we have to identify its chemical composition, which means identify the numbers and types of the elements. That's a chemical formula. So, it turns out that in the Earth's crust, there's two types of minerals. There are the silicates, which are composed of both silicon and oxygen, and that's a majority of the minerals. And then for those minerals that don't contain silicon and oxygen, both of those, that's a smaller number of minerals, only about 10%, well then it's composed of the other elements here. Okay, this is not something to memorize, it's just interesting. If you want a flow chart of all the minerals, you can split them into silicates and non-silicates, right? So if you look down the silicates first, there's those that are magnetic and those that are not. And there's a bunch of examples of those minerals. If you look over here in the non-silicates, you got a whole bunch of different things. The carbonates and sulfates. Carbonates, you're going to find this in their chemical formula somewhere. Sulfates, you're going to find this. Oxides, usually a -2. Sulfides, a -2. Phosphates. And halides. That's like chlorine and fluorine and bromine and iodide. And then you have your native elements like gold. Copper, silver, diamond, sulfur. Okay, how was this flow chart put together? Well, there's several things you can look at. So if you need to identify a particular mineral, four main things to look at. The crystalline form, its shape, the shape of the crystals, or the hexagons, cubes, whatever. Its hardness, how resistant it is to scratching. Cleavage and fracture, well, break a piece off and see how it breaks. Does it break off in nice plates, or does it have an uneven breakage point? And you can also look at density. Remember, density was defined as mass per unit volume. Okay, and you might think about colors being helpful. Well, it turns out that color in minerals is usually due to impurities. And as an example, here's some crystals formed of aluminum oxide. And with some impurities, and look at the variations in colors. So if you're curious about the impurities, well, you can read this. Pause the video and take a look at this. Ooh, and let me just highlight that rubies and sapphires are both composed of the same mineral, but the variations in those impurities give it its characteristic colors. Okay, let's move up more towards the whole geosphere. We said geosphere is composed of rocks, and rocks are composed of minerals. So now what we can do is look at three categories of rocks. Right? They're different compositions of minerals. So there's igneous rock, and we define that as rock that came from molten rock, magma, or lava. And the difference between magma and lava is its location. Magma is melted rock inside the earth, and lava is melted rock on the outside. Okay, and we have basalt and granite as two examples of igneous. Sedimentary rock is second category. Little particles, dust, rocks, pebbles, and stuff that get crushed and layered. Mild pressures and temperatures form new rock. And here's some examples of sedimentary rock, sandstone and limestone. And the third category is metamorphic rock. So if you take some older rock and keep piling more rocks on top of it, so increase the pressure and heat it up from the interior of the earth, but don't melt it, just warm it up quite a bit, and that can transform some older rocks into this new type, metamorphic rock. And here's some examples, marble and slate. You may have noticed some fossils up here in the limestone. They often appear in sedimentary rock, right? Because they're near the surface of the earth, and fossils are the preserved remains of organisms. Once you find the fossils, you don't really see or have any evidence of the original organisms. Rather, minerals have replaced those decaying organisms and left an impression or a thin layer of carbon. And here's our last topic, the rock cycle. So after a lot of research, scientists have come up with this model to explain how the different types of rocks come into being and how they're changed over time. So it's a cycle, so we can start anywhere in this cycle. Let's just start with the magma. So melted rock. So magma, melted rock. Well, it can come out of a volcano, let's say, and cool off and solidify, go from liquid to solid, and that'll create igneous rock, right? Igneous rock comes from melted rock. So maybe the slopes of the volcano contain igneous rock. And then over time, the rain comes down, the wind, other boulders, crushing boulders as it slides down, and you get little particles, and these particles kind of drift and collect and form our sedimentary rock, get pressurized and fused together. And these particles then become rock, sedimentary rock, and that process has a name, lithification. Lithification is the conversion into rock. Now, as more sedimentary rock piles up on top of this sedimentary rock, then you get new layers. And as the rocks descend in the earth, they get farther down below, and there's more heat down there, and there's more rocks piling up on top of them, so the pressure increases, and that's enough to change them into metamorphic rock. Now you might be asking, how are they sinking? Well, this happens over a lot of time. So the magma comes out and creates a void down here, some room for the rock to sink down into, and then the magma comes up here, makes igneous rock, makes sedimentary rock, and keeps the whole process moving. And then that's kind of like following the full circle, going from igneous to sedimentary, the metamorphic. Well, in the rock cycle, you can jump a few steps. So let's say you make the igneous rock, and then it gets piled up on and gets buried. Well, it can be changed directly into metamorphic rock and just skip the sedimentary. Or the metamorphic rock might be pushed back up to the surface, uplifted, and then reform into sedimentary rock. All right, that's enough for now. I'll see you in class.